Welcome to the course note for the quadratic function. So let's look at what is quadratic function. Okay. So this is actually, I would say, one of the most important chapter in this year. Okay, quadratic function, because if you are going to science option next year, if you take, let's say, science, physics, or chemistry, or both, and then you might be using this kind of function in the course as well. So you would actually want to know this function very well, because we'll be using this next year. You will be using this in CJEP. So a lot of times we'll be using quadratic function. What is quadratic function? There's actually another name for it. It's called the second degree polynomial function. Why does it call second degree? Okay, so what we have learned in Sec 3 is we have a linear function, right? So this is y equal to ax plus b, and x is actually to the power exponent of 1 because it's basically degree 1. So we call this the first degree polynomial function, but we don't really use that name because first degree is like just a line, so we will just call that a line, right? Now, second degree is, we call this parabola as well, and it's basically to the power of 2. Okay, so this is a second degree polynomial function. Now, we have 3 different forms. So in linear function, we have learned that it's y equal to ax plus b. We learned one form. We actually have 2 other forms that we'll be learning in the next few chapters. But in here, I'm going to show you all 3 forms for the parabola. Okay, so first of all, what we have here is actually we have this 3 different forms, and standard form, general form, factor form, and the coefficient a, the parameter a, is actually the same value in all the form. Okay, so what is in common in this 3 form is the a. Okay, the value of a are the same. Now, if we look at this, if a is bigger than 0, positive, it's open upward. If it's negative, it's open downward. And h and k is actually the vertex. We call this the vertex. So we can actually look at the table here. Okay, so we have standard form, general form, and factor form. The most that we use is standard form and general form. It's less common that we see factor form, but we have to learn that in this chapter. So in later years, you'll be seeing general form most of the time. Okay, standard form will be gradually, you won't see that more often in CJEP. In next year, you will still see standard form, but general form is the one that we use most of the time. So the vertex is actually the tip of this parabola, right? And in the standard form, we have h and k. Remember, the equation is x minus h. Eh? So the h, the value of what we see here, is always the opposite value. So we'll see that in the examples. Okay, so h and k is actually from the standard form. In general form, we have actually formulas to find that. So this is h equals to minus b over 2a. So we see that a, b, and c, right? So you have to really be careful on these. Remember to extract the correct coefficient. So you have to always put that in order. So ax squared plus bx plus c, the constant. Okay, and k has 4ac minus b squared over 4a. So this is a formula that we use, but most of the time once we have found h, we can just plug in h into the equation to find what is my k, because k is equal to ax squared plus bx plus c. So we place all these values into the x, then you will find your k. Okay, so that's why this formula is not very commonly used. Most of the time, we just need to remember the h, and then we plug it into the formula, the function. Now, the factor form, we have both 0. What is 0? It's the x-intercept, right? So you're basically using this formula to find your h. Okay, h equals to the average value of the 0. Why is that? Because this function is symmetry, right? So when we find the two 0, the middle point is my h actually, right? So that's what you need to know. Now once you found h, you just plug in the h into your x, then you'll be able to find out your k. Okay, so it's same thing as the second method of your general form. Okay, just plug in the h value and find your k. So that's why we don't really try to remember the k formula here for the general form. So these are the things that we need to know. Now, to find the x-intercept, so this two thing is actually the most important. Okay, so that's why I put it into a special table here. So to find these two things first all the time. So method 1 to using the standard form, okay, to find out my 0 is actually plug y equals 0 and isolate x. Okay, so put y equals 0 and find out what is x. Method 2 is using the formula. So we have two formula. So we have two answer most of the time, but sometimes it won't. Sometimes just let's look at that. If minus k over a is equal to 0, so the first thing that you need to do when you see these three forms, right, is identify what's a hk or a bc or a and both zeros. That's the first thing that you need to do to find out to work with the quadratic function. Now, if minus k over a is equal to 0, we have 1 0. If it's smaller than 0, we have no 0. If it's bigger than 0, we have two zeros. Okay, so we have two intercepts. So remember, this is our x-intercept is touching the x-axis. How many points is touching it? It's either 1 or 2 or none of them. Okay, so what happened is no 0 is when it never touched the x-axis, right? If it's 1 0, it's just the vertex that is touching the axis, and 2 0 is actually intersecting the x-axis. So that's what it means. Okay, so two methods: either isolate x, replacing y by 0, and then or use the formula. Now this year will be easier to use the formula, but you won't be remembering that for next year and in CEGEP. So most of the time we'll be using method 1 in CEGEP. Okay, just isolate your x. Okay. Now same thing with general form. We put each factor equal to 0. So factorize, put each factor equal to 0, isolate your x. So we need to find out what is x. So always isolate x. Second method, this is the quadratic formula. So we call this quadratic formula, and you will have to remember this all the time. Okay, in next year, in CEGEP, university, everywhere. Okay, and everywhere. It's literally everywhere because we use this in physics as well. Now, in calculator, you'll be able to actually find out the answer right away. So I'll probably make a YouTube video on this, on how to use it, or how to find these values on the calculator. So, but for now, you need the step. So anyway, in secondary 4, you need the step to find out what are the values for this. So you have to use the formula and plug in the value and type it in your calculator and figure out what are the x's. Okay. Now, same thing as the standard form, we can use the test. So whatever happened is inside the square root. You see, inside the square root is b squared minus 4ac. Same thing with the other one. Minus k over a is minus k over a. So we take the argument in the square root to figure out how many zeros we have. Why does it look like that? Because if we have a square root of a negative number, this doesn't make sense. If it doesn't make sense, that means that's negative, right? And there's no 0. If square root of 0, well, it's just equal to 0, so there's no more square root. So plus or minus 0 is just 0, right? So it becomes the same answer. That's why we have 1 0. If we have something else that is bigger than 0, so let's say 2, then we'll have probably 2 zeros, okay, in both cases. Now, to find the x-intercept in the factor form, we already have that in the equation. Okay, z1 and z2, those are the zeros. This form does not exist if there is no 0. Okay, so this form if it's no zero, the factor form does not exist. So that's why we don't see this form often. Okay. So we just to let you know, so if there's 1 0, we'll have a bracket square. Okay, so it will be the same bracket, so that's why we have 1 0. If we have 2 0, we will have two brackets, just like in the factor form, right? So we have two brackets. If we have just one bracket to the square, then it's just 1 0. Okay, so let's look at the properties now. So those two were the properties as well, the vertex and in the zero. Now the domain, if there's no situational problem, the domain is always R, all real number, or minus infinity to infinity. And we look for the value of X to represent that. Now the range, the image, is basically when A is positive, is K to infinity. Okay. When A is negative, it's minus infinity to K. So because that's basically open downward and that's open upward, right? So that's why it's from the K to positive infinity. And this is from negative infinity to your K. K is right at the vertex, right? And we use the value of K, which is the Y value. Now, Y-intercept is basically put X equals 0 and figure out what is Y value. Okay, so plug in X equals 0 and find Y. And the answer is basically the Y value. Now, variation, increasing and decreasing. When does it increase and when does it decrease? Okay, increasing is when it's opening upward. Increasing is actually the part that is going up. So from H to infinity, we represent this using the value of Y, the X, sorry. So always using the value of X. That's why I have to use the arrow that is horizontal, looking at the X value. So from H to infinity is increasing. From minus infinity to H is basically decreasing. So it will be the reverse when it's opening downward. Okay, increasing is from minus infinity to your H, and decreasing is from the H to infinity. Okay, so you can either remember this or draw the picture and figure it out yourself. Okay, so I let you to choose this year. So next year you probably will just draw it out and try to figure it out, because you won't be remembering which one is which, right? Because we'll be learning a lot of function later on. Now the sign, the positive and negative, always use a sketch. It is always easier. Okay, so we can always follow this. If it's positive, opening upward, so positive would be all real number, and there's no, it's impossible to have negative, there's no zero. If there's 1 0, positive is all real number, negative is just the 0. Remember, if it's strictly positive or strictly negative, then the point that is touching the x-axis doesn't count. If there's the word strictly, you don't count the 0. So in this case, it won't be have any value if it's strictly negative. Now positive or negative, when it's we have 2 zeros, then it's from minus infinity to 0. The first 0, that will be positive, and the second 0 to the infinity will be the also positive. So everything is on top is positive. Negative is from the 0 to the second 0. Well, same thing when A is negative, it's just opening downward. Everything is reversed. Okay, so you can take a look on this. Extremum when A is bigger than 0, so opening outward. Okay, there is a minimum value at the vertex. There's no maximum. But when it's opening downward, there's a maximum value, but there's no minimum. And this is also looking at the value of Y. So the sign is actually looking at the value of X all the time, right? Now, axis of symmetry, that's special for this function because there is a symmetry function. So X equals to H is my axis of symmetry. Okay, so here to sketch the graph of a parabola is actually not too hard. Okay, so the first thing we need to do is look at the H and K. So we need to put the H and K on the graph. Okay, that's the vertex. And then if we look at the A, the parameter A, the parabola, oh, here is actually, I misspelled it. This is parabola, okay, it's open upward. Okay, if A is positive, then it's open upward. If A is negative, it's open downward. Okay, so this is, again, I misspelled it, parabola. So I'll be fixing that in the notes probably. Then just bear with me because it just changed the word. Okay. Then, so look at the A, positive, open upward, negative, open downward. So sometimes the teacher will actually ask you to put the 0 and the initial value, and that's it for the sketch. Okay, that's all you need to do. Now, if we look at the study of the function, okay, so we need to actually put down, first of all, put down what is A, H, and K. My A here is basically 2, H is 1. As always, the opposite sign, hey, because the equation is basically 2 times x minus h squared plus k. So the equation has the negative in it. So my h here is actually positive. So it's always the opposite sign of what we see from the equation. K is going to be minus 18. Now the k is exactly with the sign, okay? Because in the equation is a positive k, plus k. Now with that, we can actually draw a little graph. And where's my h and k? My h and k is 1 and minus 18 somewhere here. Okay, and then A is positive, so it's opening upward. Now what is the domain? The domain of this function, okay, so I'll use orange. The domain is basically from minus infinity to infinity. Okay, so we can actually use this bracket because it's excluding, or we can use R, or real number. Now image, okay, or we call this the range, I would say. I'll put range, it's a more correct term in English. The range is basically from the lowest point to the highest point. The lowest point is actually minus 18 to infinity. So excluding, including. All right. Now we need to find the initial value. Which is going to be x equals to 0 and y equals to what? So we just need to plug it in. Y equals to 2, 0 minus 1 square minus 18. And then if we calculate this, it's going to be minus 1 square, which is 1. Times 2 is 2. 2 minus 18 minus 16. So my initial value is actually minus 16. Now how about the 0? Okay, the 0 is going to be y equal to 0. So you have to make the equation equals to 0 and solve for x. Okay, let me write this nicely. Solve for x. Well, how do we solve for x here? We can isolate my x here because this is in the standard form. Okay, standard form, if you look back the table in the notes, is there's several ways to do this. Is either using the formula or isolate your x. Okay, I would isolate the x right here because this is the most common technique that we'll be using later on. So nobody will be remembering the equation. The only equation that you will be remembering is the one to solve for 0 in the general form. Okay, so now here this is going to be 18. So I have to put the minus 18 on the other side, right? Putting on the other side will become positive 18, which is equals to 2x minus 1 squared. Now, if I divide it by 2 on both sides, this is going to be 9 equals to x minus 1 squared. And the next step is to do a square root. When we do a square root, that means we need to put a plus or minus in front, always. Okay, no question asked when we put ourselves the square root on both sides. Okay, the side that is not cancelling the square, we have to put a plus or minus. Okay, now why is that? Okay, because let's say 3 squared is equals to 9, right? We know that also minus 3 squared is also equals to 9. So that's why we have the answer 3 and minus 3. So that's why we have a plus or minus 3 equals to x minus 1. Now we have to separate into 2 to solve for x. Okay, because of this we have to put plus or minus. Remember that, that's very important. Now I have positive 3 equals to x minus 1. That means x is equals to 4. Then on the other side I have minus 3 equals to x minus 1, and then minus 2 equals to x. So therefore my 0 would be minus 2 comma 4. We are putting this in the curly bracket because we are enumerating the values. Okay, so this is important. Now that I have this, I want to do the function increasing. If the function is increasing, we look at the graph. Starting from the vertex on the other side, this part is increasing, right? So if this part is increasing, we write the value of x from h, which is 1, until infinity. Okay, so I'll use the round bracket on that side. Now if the function is decreasing, so on the other side, so it's from minus infinity to 1. Alright, now how about the positive and negative? So the function is positive when x is element of, so positive is actually everything that is on top of the x-axis. So we have to find the 0 basically. So from minus infinity to the first 0, which is minus 2, right? And then here is actually 4. So those are my two 0, minus 2 and 4. So that I have minus infinity to minus 2, inclusive, okay, excluding minus infinity, union from 4 to infinity. So this is basically everything on top of the x-axis. Now how about the negative? When the function is negative, okay, again remember smaller or equal to 0 is negative. Okay, again without the equal sign, we call this strictly positive or strictly negative. Okay, and without the equal sign, then you have to exclude the 0. But right now we include the 0 because we have an equal sign. Now this is going to be in between those, so it's actually minus 2 to 4. Include both ends because both of them are 0 because we have the equal sign here. Smaller or equals to 0. Now how about maximum? Maximum, we don't have anything. Minimum, we have the lowest point, which is my k, which is minus 18. We can actually see this from the range. Minus 18 is the lowest point. Maximum is infinity, which does not exist. How about the axis of symmetry? Axis of symmetry is always x equals to my h. H is 1 here in this case, so that's why x equals to 1. That's my axis of symmetry. Okay, so this is the study of a function. Now look at the transformation of from one form to the other. Okay, so if we want to transform from one form to the other, what do we do? Now the parameter a has the same value for all the form. That's the key point. Okay, now from standard form to general form, what do? We actually multiply and simplify. Okay, so the standard form, we just expand the bracket. So this is going to be equals to 2x minus 1 times x minus 1 minus 8. Now we have to multiply the binomial. This is going to be 2 times x squared minus x plus 1 minus 8 and equals to 2x squared minus 2x, oops, x squared minus 2x plus 1 minus 8. Then we multiply the 2 inside the bracket. 2x squared minus 4x plus 2 minus 8, which is going to be 2x squared minus 4x minus 6. Now you see this is actually my general form, ax squared plus bx plus c. So we know that a is 2, b is minus 4, c is minus 6. So this is actually my final answer. Okay, I'm going to use the same example all over to transform one form to the other. So that way you will understand much better. Okay. Now, transform from standard form to factor form. In this case, I'm going to look at the same example, okay, and to see how can I do this, because into factor form is basically find the zero and replace them in the factor form. If there's actually no zero, which means the factor form does not exist, okay, so it's very important to notice that. So how do we find the zero? To find the zero is y equals 0 and x equals to the value that we want to find, so we have to put it equal to 0 and try to isolate the x. So I'll put the minus 8 on the other side, so it becomes 8 equals to 2x minus 1 square. Divided by 2, going to be 4 equals to x minus 1 square. Now at this point, I have to put myself the square root. When I put square root, I have to add the plus or minus sign. So that will become plus or minus 2 equals to x minus 1. So I'll have actually two answers from here. So positive 2 equals to x minus 1. So x equals to 3. And on the other side, it's minus 2 equals to x minus 1. So actually, minus 1 on the other side would be plus 1. Minus 2 plus 1 is going to be minus 1 equal to x. Now, my a is actually 2, right? That's the parameter of a right here. And what is 0? My first 0 is going to be minus 1. My second 0 is going to be 3. Now all you need to do is use the factor form. And replace all these variables, which is going to be f of x equals to 2x plus 1, because it's minus 1, right? It's, in the equation, it's actually minus, so it's actually changed the sign. Minus minus becomes a plus, and then x minus 3. Okay, so this is actually my factor form. Now, if the 0 doesn't exist, that means I cannot solve for x. That means the factor form does not exist, so you cannot transform that. Let's look at the next one. The next one is transforming the general form to standard form. So how do we do this? Actually, there's several methods, right? The first method is set completing the square. Okay. As I said before in the factoring chapter, completing the square is a technique that is optional in secondary 4, but it will become something that you will need to know in Sec 5. So I'm going to show you here as well. So in case your teacher is showing you this year. X squared minus 2x minus 3. All I need to do is add the b over 2 square, right? Now, I have the 2 in front. Now, the coefficient of x squared is 1 now. So I can perform my completing the square. My b is going to become minus 2, right? So I have b over 2 square minus b over 2 square minus 3. I have x squared, oops, so my b is going to be minus 2x plus, now I have minus 2 over 2 square minus 2 over 2 square minus 3, and this is going to become 2 times, now this is actually my first 3 terms, which is my perfect square, right? So minus 2 over 2 square is just plus 1 and then minus 1 minus 3. So the first 3 terms is the perfect square equals to x minus 1, because the negative sign follow here, and then it's the square root of the 1, which is 1. So this is square minus 4. Minus 1 minus 3 becomes minus 4. Now I just need to multiply the 2 inside the big bracket. So it becomes 2x minus 1 square minus 8. Now this is from what we had before, right? This is the same example. That's why I want you to see it from the same example that, oh yeah, this is actually from before, from the standard form to general form, and now general form to the standard form. Now that's the first method. The second method is to find the h and k and then replace them in the standard form. Okay, so that should be using the formula. So this is more common because completing the square is actually harder to do, it's longer to do. So most students will actually still remember this formula in Sec 5 or in CJEP, so that's actually going to be helpful. H is going to be minus B over 2A. So what is my A? A is 2, B is minus 4, and C is minus 6. Now to find H, I just need to replace minus 4. Okay, because the equation has a minus, but the B is minus 4, so that's minus 4. Very important to remember. Now 2 times A, which is 2, I'll have actually 4 over 4, which is 1. So my H is going to be equals to 1. Now that my H equals to 1, I don't need to remember the other equation because I'm going to substitute into the equation. So my K is going to be 2 times, so I'm just using the original function, 2 times x. My x is actually my h, right? So I just need to basically do this, right? So so this is actually the original function, 2 times x squared minus 4x minus 6, pardon. Then my x is my h, so then my y is my k, okay? Now, what is h? H is 1 squared minus 4 times 1 minus 6. This is going to give me 2 minus 4 minus 6, which is minus 8. Okay, I have my k equals to minus 8 now. All I need to do is put in the equation. Now I know my a is actually the same, so that's 2. My h is going to be 1 minus 1 squared minus 8. So this is actually my standard form, right? Now I just want to acknowledge you that why are we doing f of x? F of x because it's basically plugging in numbers, right? In this case, we are actually seeing f, because in CJEP, you probably see something like this. Why do we always use f of x? Okay, f of x is just in high school that we have one dimension. Now, if with two dimensions, x and y, a function that depends on x and y, it could be something like this, x squared y plus xy. So this is actually my function that depends on x and y. So this actually can be z. Okay, this is the three-dimensional thing. Now also, you can actually have a fourth dimension depending on x, y, and z. Okay, so this is why we always use the function depending on x instead of using always y equals to something. Okay, because y equals to something most of the time is just high school thing. Okay, in university or CJEP, we mostly write function in terms of x or in terms of x and y or in terms of a or in terms of any other variable. So that's why it's important to use function of x. In high school, f of x equals to y, but in CJEP and university, it might not. So it can depend on different variable, it can depend on other things. So that's why it's important to know this for now, okay? So that you will actually get a hands on using f of x instead of writing y all the time. But I will be alternating f of x and y since we are still in high school. But just for you extra knowledge to know that later on it might change. Now the next thing is to transform from general form to factor form. Okay, from general form to factor form, how do we do this? Now the first method, again, there's actually two methods. The first method is to factorize to have the factor form. Okay, if it's not possible to factorize, that means the factor form does not exist. Okay, first we have a equals to 2, b equals to minus 4, c equals to minus 6. Now product and sum, okay, because we are in Sec 4 and the government ministry want us to learn the product and sum, so that's what I will be doing here. Otherwise you can use a try and error. Okay, 2 times minus 6, which is minus 12. I have b equals to minus 4. I need to find two factors that gives me minus 12. When we multiply, when we add them, it's going to be minus 4. So how about minus 6 times 2. Minus 6 times 2 is going to be minus 12, and minus 6 plus 2 is going to be minus 4. So these are actually my two numbers. So I will have, let me write in another color. So I will have 2x squared minus 6x plus 2x minus 6. So I replace the minus 4x over there. I need to group them now. So I have 2x squared minus 6x plus 2x minus 6. Now, because it's a plus, I don't need to change any sign. I'll have to find a common factor now for both brackets. So I have 2x and x minus 3 plus 2x minus 3. All right, so I factored out the 2x on the first term and the 2 on the second term. So there's two terms. Okay, for me, I see only two terms because terms are separated by plus and minus. Anything inside the bracket, I don't look at them as a term unless I only look at the bracket. Inside the bracket, how many terms we have, okay? But from the outside, from the whole equation, we have only two terms. Now I factor out the minus x minus 3, and then I will have left with 2x plus 2. Okay, now 2x plus 2, what can we do? We can actually factor out the 2. Okay, so I'll put it in front. And this is going to be x plus 1. Okay, so this is actually my final answer for the transformation. This is actually my factor form. My a is 2, my first 0 is 3, the second 0 is minus 1. So as what we found it before, right? Because this is the same example. Now the second method is to find the 0 and replace them in the factor form. So how do we find the 0 from the general form? So again, I have to identify my a, b, and c. My a is 2, b is minus 4, c is minus 6. Now to find the 0, I'm going to use the quadratic formula, the formula minus b plus plus or minus. Okay, actually I would actually use it like this. So the 0 is going to be plus or minus square root of b squared minus 4ac over 2a. So to plug it in, okay, b is going to be minus 4 plus or minus a square root of minus 4 squared minus 4 times a, which is 2, times c, which is minus 6, over 2 times 2. Now if we calculate this, it's going to be 4 plus or minus square root of 64. Okay, over 4. Now with plus or minus 64, that's basically 4 plus or minus 8 over 4. Now I have plus or minus 8, right? So the first 0 is going to be 4 plus 8 over 4, which is going to be 12 over 4, which is 3. My second 0 is going to be 4 minus 8 over 4, which is minus 4 over 4, which is minus 1. Now my factor form is a times x minus first 0 times x minus a second 0. If we plug it in, a is 2, x minus 3, and x plus 1. And that's basically my factor form, and that's my final answer here. So you have two methods. Okay, I would think that is actually better to use this method, because sometimes if we cannot factorize, we are wasting time trying to find factor. We're trying to see if we did any mistakes. But here we just need to remember the formula and plug it in to see if we actually find a 0. If we cannot find a 0, that means inside the square root is a negative. If we see a negative inside the square root, that means we don't have 0. So at this point, you already confirm that, oh, I don't have 0. So I find that this is actually better, but some people can factorize very fast, so maybe it's in their advantage to use the other method. Now from factor form to standard form. Factor form to standard form, all we need to do is to find the h and k and then replace them in the standard form. Okay, the equation to find the h is basically the first 0 plus the second 0 over 2. This is basically the average formula, right? So I will have my first 0 is 3, my second 0 is minus 1. and my a is actually 2. So all I need to do is plug in 3 plus minus 1 over 2 is going to be 1. So 3 plus minus 1 is actually 2. 2 over 2 is 1. So my h is 1. Now to find my k again, I just need to plug in the h inside the x, which is, I plug in 1, right? So the equation is h minus 3, h plus 1, and all I have is 1 minus 3 and 1 plus 1. And this is going to give me 2 times minus 2 times 2, which is minus 8. All I need to do now is plug it in. F of x equals to a x minus h squared plus k, right? That's the standard form. And a is 2x minus 1 squared minus 8. And this is my final answer. Now transform from factor form to general form. We multiply, okay? It's just as simple as this. This is just multiply the bracket. Okay, draw this, and we multiply. 2, and then we have x squared plus x minus 3x minus 3. And then we have x squared minus 2x minus 3. We multiply the 2 inside, so we have 2x squared minus 4x, oops, and minus 6. And that's my general form. Now that we finished all the transformation, now that you know how to transform one to the other, now it's important to actually figure out how to find the roots now. Okay, finding the roots, we have several cases. Okay, this is actually basically we use these cases to solve situational problems. I'm not going to solve any situational problem because from the situational problem, if you extract all the information, then you just need to choose the right method in this section to use to find your answer. Okay, understanding the problem is something that you will have to practice. Okay, so I am not going to say too much on that. You will have to practice. If you have questions, you can always ask on my question math website. Now, we only able to look for the standard form and the factor form. Okay, to find the rule, we can only find the standard form and the factor form. To have the general form, we need to find the standard form or the factor form first, and then we transform it into the general form. So we have two choices, standard form or factor form. Never the general form. So remember that, okay? Never general form when we look for the rules. This is only for Sec 4. Okay, I know that there's actually school will ask you to find the general form using 3 equations, but this is not the scope of high school here. You will be able to find that in SAGEP. Okay, so I'm not going to focus too much on that. I only saw one school was teaching that, but I think it's not very, the level is a bit too high. I think it's just too hard for you guys for now. For sure, you'll be able to do it, but you need more practice on that first. Okay, so with 3 different equations, you solve for 3 unknowns, 3 variables, so to find this general form. But I'm not going to say anything on that. Okay, so remember, no general form, just factor form or standard form. Okay, the vertex and a point. So we know the vertex and a point. How do we find the equation? Okay, if the vertex is given, we are supposed to look for the standard form. So if we are given the vertex h and k, so for sure we use standard form, right? Because we know h and k from the equation. We replace the h and k in the standard form, and then we place the point in the x and the y. Afterward, we solve for the variable a. So let's look at the example so that you will understand much better. So we have h and k, the vertex, and a point. The equation is f of x equals to a x minus h squared plus k. Okay. What we have here now, I would just make it into y equals to a x minus 1 squared minus 8. So I replace my h and k. Okay. How about the point? I'll just now plug in the point. Minus 6 equals to a 2 minus 1 square minus 8. And I just need to calculate. 2 minus 1 is 1. 1 square is actually 1. So I have a minus 8 equal to minus 6 on the other side. I will move the minus 8 on the other side, will becomes plus 8. Minus 6 plus 8 is going to be 2 equals to my a. So therefore, my equation f of x is going to be 2 times x minus 1 square minus 8. Okay, so I know the h and k, so I'll use the standard form. And then replace h and k, replace the point to solve for a, and then we found the equation. Now, if we look at the, if we are given the 0 and the vertex, so what are we going to do? If the 0 and the vertex are given, we can look for the factor form or the standard form. So I'll be doing both cases. Either we replace the 0 in the factor form and replace the vertex in the x and y and then solve for the variable a. Either we replace the h and k in the standard form, replace one of the 0 in the x and y and then solve for the variable a. So let's look at the first one. I'll start with the factor form. Okay, so since I have the two 0, I will actually put it in the factor form. So my factor form is ax minus c1, or this first 0, and x minus the second 0. I'll replace it with y because in this case we are using y, but you know, in the university this might representing something else. Okay, so just let you know it's not always y. Now a we don't know. My first 0 is actually 3, second 0 is actually minus 1, so it becomes plus 1. And I plug in the point h and k, the vertex, into it. So I have minus 8 equals to a times 1 minus 3 and 1 plus 1. And this is going to give me minus 2 times 2, which is minus 4. A equals to minus 8. Now, dividing by minus 4, I'll have 2 equals to a, and then my equation is going to be f of x equals to 2 times x plus, minus 3, sorry, minus 3 and x plus 1. Okay, so this is how we find this. If we are given the h and k and the both zeros. Now, if we use the standard form, so how does it look like? Because we are given the h and k, so we can actually use the standard form, right? So f of x equals to a x minus h squared plus k. I have y equals to, so we replace that with y, a times x minus 1, because h is 1, squared minus 8, which is my k. Now I just need to plug in one of the 0. Let's say this is basically, the 0 is basically the 3, comma 0 or minus 1, comma 0. I'll just use the 3, okay? I just need to use one of the 0. And this is 0 equals to a times 3 minus 1 square minus 8. Remember, 0 is basically the x-intercept, so it actually is on the x-axis. That's why the value of y coordinate of the 0 is always 0. Okay, you can replay what I just said, okay, if it's too fast. Now, 0 equals to 3 minus 1 is 2. 2 squared is going to be 4. So I have 4a minus 8. And then I'll move the minus 8 on the other side, will be 8 equals to 4a divided by 4 on both sides, which is 2 equals to a. Now my final equation for the standard form is going to be f of x equals to 2 times x minus 1 squared minus 8. And this is my answer. So again, in this case, we can actually use either one of the equation. Now, next one is basically the 0 and a point. If we have the 0 and a point, what do we do? Okay, we're supposed to look for the factor form because we have the zeros, okay, and we plug in a point to find my a. So let's start with that. I have f of x equals to a times x minus first 0 and x minus second 0. Y equals to a times x minus 3 and x plus 1. So those are my zeros, right? So I just plug it in. Now I just need to plug in x and y. Minus 6 equals to a times 2 minus 3 and 2 plus 1. I'll have minus 1 times 3. So minus 1 times 3, which is minus 3, right? So I have minus 3a equals to minus 6 on the other side, divided by minus 3 on both sides. So I'll get 2 equals to a. And basically my equation is going to be f of x equals to 2 times x minus 3, x plus 1. And that's it for this, right? Now, another situation. So all this is when you have the situational problem, you found all this information, which way you are going to find your rules, okay? So these are the techniques to solve for your situational problem, okay? Extracting the information is for you to do it, to practice, okay? It's very important to practice on that. Now, if I have 1 0 and 1 h and a point, what do I do? We're supposed to look for the factor form, okay? And then we need to use the h equals to the 2 0 add up together divided by 2, okay? Now let's look at that. So I have the first 0 and I have the h. If I use the h equals to 0, 1 plus 0, 2 over 2, I'm going to get, if I replace my h by 1, my first 0 by 3, plus second 0 over 2. Well, I need to solve for second 0, basically, right? So I will have 2 equals to 3 plus a second 0. We remove the 3 on the other side, so I'll have 2 minus 3, which is minus 1, equals to second 0. So my second 0 is minus 1. Now I have both 0. I can actually use the factor form. Alright, so if I have that, I'll have to plug it in. Replace f of x by y. X minus the first 0, which is 3. Second 0 is minus 1, which is plus 1 here. Now replace the point. What is the point again? The point is 2 and minus 6. So by replacing that, minus 6 equals to a times 2 minus 3, 2 plus 1. And this is going to give me minus 3a, because 2 minus 3 is minus 1, and then 2 plus 1 is 3, so that's minus 3. So on the other side is minus 6 on we'll divide it by minus 3 on both sides, so I'll have equals to 2. Now with that, I have my answer as f of x equals to 2 times x minus 3 and x plus 1. Okay, you see, using the same example, you understand better because we know the answer is correct, right? So it's easier for us to figure out, okay, or my A is for sure is 2, so I didn't do any mistakes. And you see the technique on how to find the equation. It's very important. Okay. Now the next one. Next section is to solve equation. Okay. To solve the equation, step to find the value of x. Okay. The standard form and the general form. One side of the equation must be 0. So we put the equation equal to 0 using the inverse operation. Find the value of x using the method to find 0. Let's look at how we are going to do this. Some people just don't get from the words, right? So if you get from the words, good for you. If you don't get it, it's fine. I'll just do the example here. So I've moved the 10 on the other side, so I'll have the equation equal to 0 always. Okay, 2x squared minus 4x minus 6 minus 10. And this is going to be 2x squared minus 4x minus 16 equal to 0. And then my A is 2, B is minus 4, and C is minus 16. I'll use the quadratic formula. You can factorize if you want, but I'll use the quadratic formula in this case so that you can practice to remember the equation. Okay, it's very important to remember this equation. The whole thing over to A. Now, plug it in is basically minus 4. which is plus 4 plus or minus square root of minus 4 squared minus 4 times a, which is 2 times c, which is minus 16 over 2a. Okay? Over 2 times 2, sorry. Now I have 4 plus or minus inside the square root here. If you calculate it mentally or using calculator, it's going to give you 144 over 4. And this is going to give me 4 plus or minus 12 over 4. Now I'll have two answers, right? Again, because I have plus or minus, I'll use red, okay? So my first zero is going to be 4 plus 12 over 4, which is going to give me 4. My second zero is going to be 4 minus 12 over 4, which is going to be equals to minus 2. So my x, okay, my zeros is basically minus 2 and 4. Okay, so this is actually my answer for this. Okay, the teacher might ask you to write like this, or they might ask you to write x1 equals to 4 and comma x2 equals to minus 2. Okay, so it depends, or maybe sometimes they even use elements of. Okay, so it's up to the teacher. Just follow with your teacher. Okay, if it's me, I'll accept both answers. Both of them are correct. Now with a standard form, I want to isolate my x. Okay, I'll move this onto the other side. So you can either use the formula or isolate the x. I would use isolating the x. I will use the method that most people would think, not most people, but I would say almost all people will forget about the equation and then just solve for x. Okay, then you will have to use this way, right? So I'll show you this. Move the minus 8 on the other side. I'll have 18, because that would become a plus 8. So 18 equals to 2 times x minus 1 square. I'll get divided by 2, so 9 equals to x minus 1 square. Then I'll have square root on both sides, and then I'll have a plus or minus, because I'm putting the square root myself, right? So I'll have plus or minus 3 equals to x minus 1. So I'll have two answers. 3 equals to x minus 1, that means x equals to 4. And the other one is minus 3 equals to x minus 1, then my x is equal to minus 2. So I have two answers, x1 equals to 4, x2 equals to minus 2. So again, I can have x elements of minus 2 and 4. So it's either this or that as the answer. All right. Now, how about factor form? Okay. Factor form, we need to transform it into the general form and set the equation equal to 0 using the inverse operation, and then find the value of x using the method to find 0 in the general form. So let's look at that. So this is going to be, so I have to multiply the bracket. 10 equals to 2 times x squared plus x minus 3, x minus 3. And I have to simplify in it, so minus 2x minus 3, and multiply the 2 inside is going to give me 2x squared minus 2x minus 6, minus 4x, sorry, minus 6 equals to 10, and move the 10 on the other side, so I'll have the equation equals to 0. So that becomes exactly the same example as before. So I'll actually do this quicker, or you can actually fast forward. So in this case, you can use the same method, but I'm going to do the factorization, so that since I didn't do it in the other example, I'll just do it here. If you don't like the factorization method, you can fast forward, no problem. Just move on to the next example. Okay, so my a times c is going to be 2 times minus 16 equals to minus 32. And b is minus 4. So what are the factors that will give me minus 32 but add up to be minus 4? How about 4 times minus 8? This is going to be minus 32. 4 plus minus 8 is going to be minus 4. So you have to really test out all your factor. I believe you practice a lot in the chapter of factorization, then you should be good at this. Okay, I'm getting right away because I know the answer, and I practice a lot of factorization. I know which number I need to use, but nonetheless, you should practice more to get to know how to factorize correctly. So I'll have to group. I'll actually separate the minus 4x into 4x minus 8x, right? So 4x minus 8x plus 16, minus 16, sorry. Now if I group them, okay, I shouldn't be writing the brackets here, right? If I group them, I put a bracket like this, and I put a bracket like this, but I have a minus sign in front, so that means I have to change the sign inside. Then I do the common factor, it will become x plus 2, and the other side is minus 8, x plus 2 as well, and I factor out the x plus 2, and 2x minus 8, and I need to factor out the 2 as well, because in the second bracket I have a common factor of 2. So this becomes x minus 4. And this is basically my equation. And now with this, each factor, I make it equal to 0. And this is actually the factor form. I know my 0 is going to be minus 2 and 4, right? But assuming you forgot about that, okay, we put each factor, x, so I'll use another color. I put each factor equals to 0. So x equals to minus 2, x minus 4 equals to 0, x equals to 4. So these are my zeros. So my first 0 is minus 2, second 0 is 4. Or x is element of minus 2 and 4. Okay, so it's either this or the other one. So it's very important for you to know how to do this. It's either this method or the method that I did in the previous example. Okay, so the next section here is to solve the inequality. I would suggest you, well, you can go through the step here, but I'm going to show you how to do this, okay? I think it's better to actually do it with an example so that you can see how it goes. With the wording, sometimes it's just, maybe it's confusing for certain people, so that's why I'm, for you, if you want to actually look for the step, then that will be good for you. Otherwise, just follow the example and just follow the step from the example. I think that's good enough. Now, if we have something like this, we always want to make it on one side with a 0, okay, and put everything on the other side, okay. So it's like solving 0, okay. So let's take a look on what are the, so once I have the 0, so let me just write that first. So I'll move the 10 on the other side. I'll have something like this, minus 18, because the 10 on the other side is minus 10, so that becomes minus 18. So that becomes my function. And I'm looking for the 0 of this function. And what are the a, h, and k here? My a is 2, h is 1, k is minus 18. So this is actually the method that I use to solve this inequality. Some teacher might use some different ways, okay? But I find this is more standard. It's easier to understand, so that's why I'm using it this way. Now I'm looking for the function that is greater than 0. Okay, function greater than 0. This is, I'm reading it from the right to the left, okay? Because I always want to know if I'm looking for something that's smaller than the function or bigger than the function. I'm actually looking for the function that is bigger than 0, that means it's positive. We are looking for the sign, right? The positive value of this function. So if we look for the graph, I have h and k, which is 1 and minus 18, and a is positive, so I have a graph like this. And if I look for the positive, okay, and it's basically on top, okay, I have my h and k as 1 and minus 18. Now, I'll make the equation equals to 0, so that I can forget about the bigger or smaller, because for some student it's confusing. Okay, it's easier for you to do it this way. Okay, later on in CGEP or university, if you want to stick with the greater sign, and you practice later on. For now, I just don't want most students get confused. I'll just make it equal to 0 all the time. Okay, so that is much easier to solve. Okay, in terms of smaller or equals to or smaller than, you know, sometimes students scared that, oh, do I need to flip the sign, or what should I do? So make it equal, then you don't have to worry about those, and it becomes less headache. So 0, well, I'll have to move the minus 18 on the other side, so I have 18 equals to 2, x minus 1 square. And divided by 2, so I have 9 equal to x minus 1 square, and I will have to make a square root, and I will have a plus or minus sign. And what do I have? I have plus or minus 3 equals to x minus 1. I will have two answers. Again, this is basically the same example. It's always getting me the same answer. None doesn't matter, right? So this is just this part you can actually skip over and know the answer right away, but you still need to copy it down so that you have the complete notes for this example. Now I have my two zeros, so minus 2 and 4 for these 2 points. So how do I answer? Now the answer of this is going to be x is element of minus infinity to minus 2, right? So everything on top, because I want to look for the positive, right? And including the 0, right? Because, oh, no, this is excluding the 0. Why? Because I don't have the equal sign, right? I don't have the equal sign here. If I don't have that, I have to exclude the 0, union 4 until positive infinity. So this is how I need that as my answer. So how about the general form for now? We just did the standard form, now general form. So next will be the factor form. Again, this is going to be the same thing for me to do. I'll have to put the 10 on the other side, so I'll have a 0 on one side of the equation. Minus 16. Now this becomes my function. Okay, so this is actually my function here. Just like before, I have the function that is smaller than 0. This time I'm looking for the negative side. Okay, so if I draw this, well, I don't know any information on this yet, so I'll draw this afterward. I have my A as 2, B as minus 4, and C as minus 16. I'll use the quadratic formula to find my 0 instead of factoring. Okay, you can factor if you want. It's just I want you guys to really learn this equation. So replace the B, so I'll get 4 plus or minus, if I plug it in, minus 4 square minus 4 times 2 times minus 16. This is going to give me over 2 times 2, which is 4 plus or minus the square root of 144 over 4. And this is basically my x here, x equals to 4 plus or minus 12 over 4. And I will have my equation as first x is 4 plus 12 over 4, which is 4. My second 0 is 4 minus 12 over 4, which is minus 2. So I have my two answer here, minus 2 and 4. So I'll just have something like this. This is minus 2 and this is 4. Okay, and I'm looking for something that is negative, right? So negative downstairs. That means the answer of this is going to be x element of, there's no equal. Again, you don't see the equal here. That means excluding the 0, minus 2 to 4. And that would be my interval to represent this inequality. Again, if you have any question, you can always ask me on question math. Okay. Now factor form. Okay, if you have any question that related to this subject or any subject in high school, you can always ask me on question math. Okay, so in here, let's finish up with the factor form. Okay, I'm going to let you read this on your own. Then I'll do the example. Now this example, so what should I be doing? I should be multiplying the bracket and transform it into the general form. Okay, this is how I would do it with the factor form. I'll have to multiply that. Okay, just like this. Again. So I have 10 bigger than 2x squared plus x minus 3x, oops, and minus 3. And this is going to be 2 times x squared minus 2x minus 3, and 10 bigger than 2x squared minus 4x minus 6. Moving the 10 on the other side, so I have one equation, the equation that is actually have a 0 on one side, 2x squared minus 4x minus 16. From that, I'm going to, well, again, this is going to become a general form. So I'll actually use the factor method. Okay, so I'll factorize this. First, I'll just take the common factor out. Okay, so this is something new. I haven't shown you before, that we can actually take out the common factor. And I'll be able to find my product sum y array to the answer. Okay, so I can divide by 2 on both sides. This is going to give me something like this. Because my coefficient of x squared is 1, the answer that I found with the product and sum is directly my answer. A equals to 1, B equals to minus 2, C equals to minus 8. Okay, so this is actually minus 2, C is minus 8. That's my A. And then A times C is equal to 1 times minus 8, which is minus 8. B is minus 2. So what are the factor? I would say minus 4 times 2 equals to minus 8. And minus 4 plus 2 is equal to minus 2. So I have my two factor, and those actually are my answer. So x minus 4 and x plus 2. So I will have 0, x minus 4 and x plus 2 as my answer. With that, I'll have to use each factor, make it equal to 0. So that to solve for the value of x equals to, x minus 4 equals to 0, x equals to 4, x plus 2 equals to 0, x equals to minus 2. So these are my two zeros. And on a graph, I'll just need to draw the little graph. I don't even need to draw the Cartesian plane. I just need to draw the horizontal line and put my function that is positive, because my a here is positive, right? My a here is 1, right? It's positive. So I have a opening upward graph. And my zeros are minus 2 and 4. And I'm actually looking for 0 bigger than my function. So my function is actually smaller than 0. So I'm looking for the negative downstairs. So my answer is going to be x element of minus 2 to 4. Is it inclusive or exclusive? It's exclusive because we don't have an equal sign. Okay, so this is how I do this. I always make the thing equal to 0, and my new function is on the right side, in this case, okay, it's always on the side that doesn't have the 0, right? That's my new function. Okay, some teacher would ask you to, okay, stick with the original function. I want you to find the inequality. Okay, personally I found that hard because I have to figure out, oh, I have a line that is horizontal line that is at y equals to 10, and then I will have to find out anything that below that. That's just too messy, I found. Okay, so that's why I'm actually leaving it as finding the sign, positive or negative, of the function. That I think that's actually easier to understand. So these techniques will be very helpful for your inequalities. So that's it for this chapter. Again, you need to practice a lot for this chapter. This chapter is one of the most important chapter for people who study in science, okay, or even in commerce later on. Okay, it's because you have to use this quadratic function everywhere. Okay, in physics, in chemistry, in finance, you'll be seeing this quadratic function. So this is one of the most important chapter in Sec 4. So practice more, do it well, remember it, then you'll be good for the later years, like next year and CJEP in university. You'll be fine with that. Okay, so see you for the next chapter.